Whoa! I'm faster than the speed of sound. Actually, I'm just faster than how fast my webcam can keep up with my audio. But we're on to the last one of arrays and hashing. Huge milestone. Longest consecutive sequence. We don't have to pay this time, and we can just go for it. So if you're new, I'm Sammy J. I'm doing this LeetCode across the whole entire planet of NeetCode timeline, and we're doing longest consecutive sequence where when we're given an unsorted array of integers of nums, we're going to return the length of the longest consecutive elements sequence, where I need to write an algorithm that runs in 0 event time. Oh no, it's the fastest one. Actually, I don't think it's the fastest one. O log of n would be faster, but that's not what they're telling us to do. So I guess it's not as bad as I thought. So we are given our input nums. And I'm just going to think about the notation. I'm going to say, okay, I haven't even looked at the examples yet. So let me do that because I don't know what I'm even looking at. Given an unsorted array of integers nums, return the length of the longest consecutive elements sequence. Oh. So what we do, given an unsorted array, return the length of the longest consecutive element sequence. So this tells me a few things. Starting to break it down in my mind. We have a list, and we have an array of integers where we have to sort them first. And then we can return the longest consecutive sequence by determining in some way that these stack one at a time. And we can do the same across any array, even if they are duplicate numbers. So we have 1, 2, how many nums are in here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 2 zeros, but the rest are consecutive 1 through 8. No, the rest are consecutive 0 through 8. There's a duplicate 0 at the beginning. Wow. I just sneezed a part of my soul out of my body. Oh. I'll show you what time it is. And we have 0 to 8, which is 9 characters, which is the output, which is what we would expect from this dastardly method. And we have our we can linearly look at this, or like we can iterate through to sort it. Like we can sort it first with like a brute force. I don't even know what the sorting algorithm is called. But you just check if this one is less than this one. If it's not, then you can put this at the end or whatever. You know, but it would take a long time. So what we can do is we can put all of these into a hash set and then loop through every instance of the set to see if the next one up, like the consecutive element, exists in the set. And if there's a duplicate, I guess, how do we know if there's a duplicate or not? If there's any duplicates, we'll have to create a conditional for that. So what we can do is we can create a set of numset of the numbers that exist. So we're converting this array of unsorted integers to numset. And we have our result, which will be 0 at first, because basically what this is the longest consecutive elements sequence. But what we'll do is, I think we can still loop through every variable in this nums array, but what we can do is then check it against this nums set to see if it exists already. So we're only looping through like one time, basically. One time for the one time. And we can check, we can create a conditional to say if it is the start of a sequence. So I believe this will also take care of if there are any duplicate values, which is what we need to also take into account. So we need to check if start of sequence. Check if n is the start. Oh my god. Check if n is the start of a sequence. So what we can do is we can look at this, and if n minus 1 is not in num set, what we can do is say the result, which is the length of the consecutive element sequence, is 1. So this is checking if it's not already in num set. Because it looks for the value directly below n, which is the number here, not like the value at which it is placed, like the position where it's placed. N is the actual value. So if it looks at 100, we'll say that, and if 99 is not in num set, then we know that the result is 1, or the length of the consecutive element sequence is 1. So it's like we know we can keep going to see if there are any consecutive numbers that we can plug into the sequence, or that exist as a sequence within this array. And the way we'll do that is with another loop. And we'll just look at while the number that we're looking at, n, plus the length, plus the result, which is 1, is in num set, we can add 1 to the result, or like we can add 1 to itself within result. And with this, what this will do is that as we look through numset, we can determine, I guess, what will happen is that when we find the n plus res that doesn't exist because that doesn't exist in numset because we've added 1 to the result, which is the longest consecutive element sequence. We can say that the result is going to be the maximum of the length. No, this is not res. This is length. Okay, what did I just mess up here? So if n minus 1 for n in nums, basically we'll say 100. We'll loop through the first one. If 100 minus 1 is not a num set, which it is not, well, I guess which it is not, we have length equals 1. Okay, so that is our single consecutive variable, or our single consecutive element. Then we can look at while n plus length is in numset, we can add 1 to length. So this is checking if there's any duplicates, and if there are no duplicates, then we can go through and start looking for, or I guess not necessarily duplicates, but if there's anything below, because we're checking if it's the start of a sequence with the minus 1. So if there's nothing below 199, then we know that 100 is the start of a sequence. Then while we add n plus length, which is just like a counter within numset, which is a hash map, so we don't have to loop through every position of the array, we can add 1 if we find that 101 exists, because we're looking at n plus 101. And then if 101 existed, then we add 1 to the length, which would be 2. Then we look for n, which is 100 plus 2, which would be length. So we would find 102 until we get to the end, where res becomes the maximum of length, which is the number of items in the sequence, and we have the result, which sets result equal to length, I believe. Then we can return the result. I want to know what this does, so I'm going to play with it. Oops. And I want to look at this and this. Okay, where did my... So you have numset. Nice, I like it. I like the brackets. Length equals 1. I like it. 100. What is res? Okay, result becomes 1 because length is 1. But as we go through 4, what? As we go through 200, how did that get into the picture? N is 200. What the heck? I'm not sure I follow. So if n minus 1 is not in numset, I just want to see that print. Prints 1. One. Four, which is 1, 2, 3, 4. It doesn't even go to 200. I want to figure this out. I want to know the reason why. So we have, if for n in nums, so if n minus 1 is not in numset, n is 100. N minus 1 is not in numset. So we can go to the next one. Boom. Length equals 1. Correct. Then we go to the next one. While n plus length is in numset 101, it's not. So we skip the loop. We get result is the maximum of length and res. So maximum, what this does is it just checks. This is what I have just figured out in this very second. What max does is it checks if the length that is being passed into this method is bigger than res. And if length is bigger than res, then we set res as length. So then we can go to the next loop to print res because it was the first assignment, and we print 1. Then the next statement we have if n minus 1 is not in numset, which is now 4. So n minus 1 will be 3. So if 3 is not in numset, then we can go through here, but it's not. So we skip to the next one where we go from 4 to 200. Right? So we're at 200 now. While n plus length is in numset, so n minus 1. So 200 minus 1 is not in numset, 199. So it could be the start of a sequence. And while n plus length is in numset, which is n plus 1, which is 200 plus 1 to a 1 in numset, it's not. We have length plus 1. So to a 1, which is 1. Then we can look again if, well, I guess it wouldn't work. It doesn't go. It doesn't keep adding. So it's just still 1. Because 201 is not in numset. But we've made it past these first 3 variables in num, and we're at 1 for n. And if 1 minus 1 is not in numset, which is, if 0 is not in numset, which it is not, this is correct, we have length equals 1. It continues with the if statement. And then we have length equals 1. And then we can enter this while loop, because while n, which is 1, plus length, which is 1, 2 is in numset, we can add 1 to the length. So then length becomes 2. And then we can go back through the loop to see if n, which is 1 plus length, which is now 2, is in numset, which will be checking if 3 is in numset, which it is, then we can add 1 to the length. Ooh. Then we do it again. Because we're on this roll. We're on a roll. We can say, oh, we're at 4, but 4 plus 1. If it's in numset, then, excuse me, if 4 plus 1 is in numset, we're not going to end up adding length. And we're just going to go to res where we set our new max. Boom. And that's how we get 4. And that's it. Thank you.